And now that I have erased the board, let me just start by putting a few examples of following the procedure that I just gave. So example number 1, suppose we had the following system. X plus 2y is equal to 12, and y is equal to x minus 3. Now this system is actually set up already for substitution, I would say. We could take the x minus 3 and stick it in for the y, and that would be a nice way to do solving the system by substitution. But for the sake of showing the elimination process and going through the procedure, let me label my equations. I like to label them 1 and 2. Okay. What I'm going to do now is move things around in equation number 2 so that I have it in the standard form. Okay, so with my equation number 2, y is equal to x minus 3. I'm going to subtract x from both sides. That gives me negative x plus y is equal to negative 3. And there it is in the standard form. What's nice about putting that in the standard form is that I can then show these equations right next to each other, lined up with each other. So here's what they look like now. The first one, I didn't do anything to, it's just the same as it was. The second one I changed to look like this. Negative x plus y is equal to negative 3. Now both of these are in the standard form, and I have prepared them to add for elimination, actually. We don't have to go through the step of multiplying or dividing because this system, again, is already prepared for elimination. So let me show that by adding the two equations together. Okay. And that's why doing it this way is called sometimes the method of elimination, sometimes it's called the method of addition. It's the same thing. I call it the method of elimination by addition. How about that? Okay, so add the two equations together. X minus x is 0. Effectively, that variable simply is eliminated. 2y plus y is 3y. On the other side, 12 plus negative 3, or simply 12 minus 3, gives me 9. And then I just proceed from here to solve for the y variable. Divide both sides by 3. Cancel, cancel. And y is equal to 3. Now, what I do with this guy is either back substitute into one of those original equations. So I could put the y value either here or here, and then find the x value, or I can eliminate again. So give me a second to sort of erase this a little bit. There we go. Okay. And which one do I want to do? How about, for the sake of argument, I am going to eliminate again instead of doing the back substitution. We'll see how that goes. So let me just create a little space here. And again, I'm going to look to my two equations, x plus 2y equals 12. Okay, in standard form, and negative x plus y equals negative 3. However, this time, instead of eliminating the x by addition, I want to eliminate the y by addition. But the problem is, right now, if I add these guys up, nothing gets eliminated. So what's going to provide this condition for elimination? We can see that looking at the x variables, to eliminate, one needs to be positive and the other one needs to be negative. Moreover, the coefficients have to be the same. So if I want y to go away, I've got to have a 2y here and a negative 2y there. I can get a negative 2y simply by multiplying by negative 2. But I've got to do it to everything. Okay? So I'm going to multiply the entire equation by negative 2. Keep in mind, however, in choosing this number, the only thing I was looking at was how am I going to eliminate that y variable. Now that I do that, my system becomes the following. The top equation is still the same. The next equation, negative 2 times negative x is positive 2x. Negative 2 times y is negative 2y. On the other side of the equal sign, negative 2 times negative 3 is positive 6. And now I am ready for the addition step. So from here I get x plus 2x, which is 3x. The y's are eliminated. Positive 2y plus negative 2y, or simply 2y minus 2y, adds up to 0, so the y variables go away. Equals on the other side, 12 plus 6 is 18. Finish this by solving for x. Divide by 3 here, divide by 3 here, and we can see that the 3's cancel and x is equal to 6. And now I found the solution to the system, which can be stated as a point. So let me just point it here like this. Solution to the system is, we can state it as a point, 6, 3. Remember, when you do that, if you're stating it as a point, we're kind of relating this to graphing that the x is the first one you list in your ordered pair and y is the second one you list. If you've got weird variables like z and p and l and m, then maybe it's better just to leave it with the entire expression, y equals 3 and x equals 6. Okay? Just remember that as the ordered pair implies, these have to be these numbers at the same time, okay? And it's not like one number is a solution. You have to have both numbers to constitute a solution to the system. Okay, let me pause for another moment and I'll get another